Okay, so the transformations are reflections, rotations, translations. A glide reflection, remember, it slides and then reflects. It's actually a translation and then a reflection. So it's just like what it sounds. It glides and then flips. So one should be easy. Translation. If it looks exactly the same, it's a translation. Two, you can do elimination. It's not a translation. It's not a reflection. If you turned your paper, it would look exactly the same. So it's a rotation. Three, reflection. Okay, four, it's supposed to look the same here. It just got faded. Same with all of these. So this would be a reflection. Five, rotation. If you turned your paper, it would look the same. This one is just a translation. Okay, number 7. Yep, it's just slid up, translation. I don't know why I keep putting the capital R. Number 8, rotation. And 9, translation. There was none that was glide reflection, so I should show you what that would look like. If you had something like this. Okay. This one could be a couple of different things. No, it couldn't either. If you look at, if this was slid up here and then flipped, this is an example of a glide reflection. It looks like it.
3 images or no?
Huh?
Will there be 3 images or?
No, it'll just be 2. So what you can do is eliminate, you can tell it's not a translation, it's not a reflection. A rotation, if you were to turn this, this would not be the same as that, because you see the point is still on the top. A rotation would be on the bottom. So that's how you can tell it's not a rotation. So you gotta, if it's not that, then check to see if it's glide reflection. It's gonna be one of them. Okay, so understand how that works? Another one that I think there's one like this on the test. I'll use a different color. Well, I'll use the same colors. So what's that one? Yep, it's a reflection right on this line. It's been folded on top of itself. Okay. So those are 2 that are on the test, I know, that weren't on the examples here. Okay, lines of symmetry. How many can we draw? 1, 2, 3. So remember, if it's a regular polygon, however many sides it has, that's how many lines of symmetry it'll have. So since this is a pentagon, it would have 1, 2, 3, 4, 5. A rectangle, just 2. Right there and right there. Now remember, if there's a flag like this, how many does that have? Just 1, right? Just right through there. Okay, rotational symmetry. This is something we don't do a lot of, but it's very easy if you remember what it is. They will have this if any of you take an ACT test. This is on there. When it has rotational symmetry, it means you can turn it a half turn or less, and it looks the same. So on this one, you could turn it a half a turn or less and it would look the same. So it's yes. When it says describe, that means how many degrees. Okay? So what you got to do is figure out what are the fractions of turns. From here to here, it would look the same. That's 1/4. Or you could just count the equal things. There's 1, 2, 3, 4 equal things. So you got to figure out how many degrees that is. 90. You just take 360 divided by 4. It's 90. So it has 90. Now remember, you got to go up to a half a turn, which is 180. So it's 90, and then another 90 would look the same, which would be a 180. So you got to list them all the way up to 180. Once you go over 180, you don't have to anymore. So on this one, this would be yes. 1, 2, 3, 4. Yep, every sixth of a turn. So you take 360 divided by 6 is 90. No, that was 90. 45? 60? Yes, it's 60.
Right.
So it would be 60 degree, 120 degree, and 180 degree. Every 60 degrees it would look the same. Here, if we count, it's got 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8 is 45. Is that right? So it would have 45, 90, 135, and 180.
What is it? 45?
Yeah. And this one, 1, 2, 3, 4, 5, 6, 7, 8. So it's the same as this one, right? Now remember, there could be a no in there. If it's a no, then you just put no. Like this calculator doesn't have rotational symmetry because I would have to turn it a half a turn. It still doesn't look the same. You'd have to turn it all the way around. Okay, so remember, there could be some that have no. Okay, another thing we didn't do much of, but it's easy as long as you remember what to do. To name the vector, one of the letters has an arrow on it. That's where it ends. That's the terminal. So you got to start with the P first, and then the Q, and then does anyone or does everyone remember what symbol you put for a vector? Yep, half array, a bar, but one bar on it. So that's how we name it. Then you got to write the component form. The component form is the short way, and you can't use brackets because if you write it like this, that means it's a coordinate. If you write it like this, that means it's directions how to get somewhere. So remember, vector is the opposite of slope. It's the way slope should have been. It's just like plotting a point. You don't rise over run, you go side to side, up and down. Okay? So don't get that confused with slope, although they're kind of the same thing. So to get from P to Q, you got to go right, 1, 2, 3, 4, so it's just a 4, and up 1, so it's just a 1. So on 18, the arrow is on the end, so that's where it ends. So you got to put the M first. And then the way you get from M to N, start at M, and remember you got to go side to side first. I got to go right, 1, 2, 3, 4, and then down 2, so it's -2.
45, 90.
Which one are you looking at?
Jason, sit down.
Okay, everyone got it?
Yeah.
Okay, this was like we did in the assignment. Oh, we don't have to trace it because it's there. You just got to draw the reflection. So remember, each point you just reflect across. It's got to go at a 90. So this one to here, they'd be about the same distance across. Here, remember, go at a 90. It's got to form a 90. If you want to turn your paper so it's straight across, it's that line, then it's easier to do. And then you can just kind of estimate. So this one, the point is this far away, so it'd come to right about there. These would come right about to there. Once you have one, you can kind of draw the rest.
Okay, like I have that, man. I know what to do.
Yep, no,
I just-
that's good.
Alright.
I can tell if you, I mean, we're not all artists.
Yeah.
Except for Lily.
Yep.
What?
It's tough to get it exact. The one thing I see that people do wrong when they're doing this is they'll just go like this, draw the same thing over here. That's not a that's a
That
translation.
is wrong.
It's got to be folded over. So again, if it's not exact, that's fine, but I can tell if you did it right. Okay. So these are just like we did an assignment. All we got to do is sketch 1 point. These exact types of problems are on the test. So the starting point for all of these is the same spot. Make sure you get that spot correct. Remember, this is X, this is Y. So X is 1, so you go over 1. Y is down 3, so you go down 3. So there's your starting point. There's A on all of these. 1 over, down 3.
How come it moves?
Yeah.
What was that now?
Okay, so what you got to do then to this point is do this first and then that second. So everyone know how to read these translations?
Yeah.
The X plus 2 means you go right 2, and then since there's just a Y, that means you don't move anything up and down. So the new A is right 2, up 0.
Is it right there?
Yep. So you put A prime right there. Then, so that takes care of the translation. Now we got to reflect it in the x-axis. Remember the x is side to side. So it's going to flip up here. It's 3 away, so you go up 1, 2, 3. A double prime. Okay, for 22, again, we're starting in the same spot. 1 over 3 down. First, we translate it. X minus 3 means left 3. Y plus 2 means up 2. Remember, if it's negative, that's left and down. If it's positive, that's right and up. So we go left 3 and then up 2. So there's the new A prime. Takes care of the translation. Then we got to do the reflection. In line x equals 2, does everyone know how to draw that?
Yeah.
X equals 2 crosses the x-axis at 2. So this is gonna go off the graph. So you flip it over that line, it's 1, 2, 3, 4 to get to it. So you go 1, 2, 3, 4. You just gotta estimate. So A double prime would be over there. So it slid up and flipped over. Glide reflection. So 23 and 24, it's still the same rules. We still got to start off at 1, -3. We got to slide it. X plus 5 means right 5. Y minus 4 means down 4. 5. 1, 2, 3, 4. So that goes off the screen also. So there's A prime. And then reflect in the line y equals -5 crosses the y-axis at -5. So that's this line. So A prime is 2 away, so you just go 2 up. And there's A double prime. It slid down over here and it reflected up to there. That's the glide reflection. So again, for 24, we got to start in the same spot, 1, -3. X minus 4 means down 4. Y plus 3 means up 3. So or not,
Left.
right. It's up 3, but it's left 4, right? Left 4, up 3. So we go left 1, 2, 3, 4, and up 1, 2, 3. There's A prime. So that takes care of that. Now we didn't do many of these. You guys remember what y equals x, the line is?
It's spread,
Both
spreading.
Yep, it's the diagonal. Because this is 0, 0, 1, 1, 2, 2, 3, 3, all the y's equal the x's. So when you reflect over that, you go diagonally. A prime is 1.5 away, so you go 1.5 over here. So there's the new A double prime.
That's right.
So it slid up here, and then it folded down over to there.
Negative y equals x is the other side.
Yep, y equals -x would be that one, or negative y equals x. Okay, is this the last one?
Yeah.
Okay, a rotation. Make sure you name the coordinates. Okay? The graph isn't quite big enough here, but okay, we got to find the image after a clockwise rotation about the origin. It'll be about the origin on the test too. 90 degrees. So remember, A and B are in this quadrant, so they're going to end up over here. C and D are in this, so they're going to end up down here, because that's a fourth of a turn. So these, the 90 degree, what you do is you do the opposite. A, to get to the origin, is down 1 over 3. So you do the opposite of down 1, you'd go over 1. And the opposite of over 3 is up 3. So it ends up right where C is. So A is 1 over 3 up. A prime, sorry. B is hard to mess up because it's down 3 over 3. So if the numbers are the same, I know I got to end up over here. So it'd be over 3 up 3. So that is 1, 2, 3, up 3. Now C and D are going to end up down in this quadrant. So C is over 1, down 3. So the opposite of over 1 would be down 1. And the opposite of down 3 would be over 3. So that is 1, 2, 3 over and down 1. Once you have that, you could draw it in and you would know where D goes, right?
Yeah.
It would have to go right there. And that one's hard to mess up too because it's over 1, down 1. They're the same number, so you'd go down 1, over 1. So that one is 1 over, 1 down. So, the test is just like this one. Should be